All right, so this is part 3 of Journal 34, and we are trying to find all the zeros for this function here. And in the previous, we were looking at the degree of the function and then listing out all the possible zeros and then checking the graph to see if which of the possible roots actually show up on the graph. So we're going to take a look at another example where not all of them show up on the graph. So this one here, looking at this equation, by the way, I think I made a little error. This problem is the problem that is in page 6 of the packet, number 10, and I believe that this should be a minus sign. Let me just double check all the signs. Yep, that should definitely be a minus sign. So we first want to find the degree of the function, which is the highest power. So the highest power here is 4. So this should be a 4. And then we're going to list out all the possible real zeros. So to do that, we take our constant and we take the coefficient, the leading coefficient. So the leading coefficient here is 1, right? So when we write out our possible zeros, that's going to be factors of 6 in the numerator. So factors of 6 are 1, 2, 3, and 6. These are all the numbers that can factor into 6 or can divide into 6. Now we need to find the factors of 1, but the only thing that goes into 1 is 1. So that means that now I can take all my numerator and divide it by my denominator. So 1 divided by 1 gives you plus or minus 1. 2 divided by 1 gives you plus or minus 2. 3 divided by 1 gives you plus or minus 3. And 6 divided by 1 gives you plus or minus 6. So these are all the possible real zeros. So now we check in our graphing calculator if these are the, which ones are actually the ones that show up on the graphing calculator. So remember that the degree of the function is 4, right? Only 4 of these are actually the real solution, the actual solution. But which 4 is the question? So we use our graphing calculator to help us out. So I'm going to turn on my graphing calculator. Let's see if I can turn this camera on. So I'm going to turn on my graphing calculator. Let's clear that. So you hit y equals, and we're going to punch in this function here. So we have x. We use that caret button to get our power to the 4th power. Arrow key minus x to the 3rd power. Oops, sorry, I hit the graph button by accident. Now it's graphing. Darn. Ignore that. I'm going to try to get back to my y equals. So I had minus x to the 3rd minus 5 x squared minus x minus 6. So let's make sure that that graph looks right. It does, so I'm going to hit graph. So let's take a close look at what we see here on the graph. Let's see where those x-intercepts are. Okay, it looks like it hits it at, there's 2 x-intercepts, right, that we actually see, and it's at -2 and +3. So let's write that on our list here. We have x equals -2 and +3. Well, there's only 2 on here, and the degree of the function is 4. So where are the other 2? Right? And some of you already kind of know what's going on here. The other 2 that don't show up here on the graph are imaginary. So let me pause on that video there and put that to the side here. So what I'm saying is that because we only saw, sorry, I need to get my pointer. We only saw 2 x-intercepts here, or 2 zeros here. The other 2 must have been imaginary. They're not going to show up on our list of possibilities because these only list out the real zeros or the real solutions. So the only way that we can find out the imaginary solution is by using synthetic division. So we do it by using the roots that we already know to narrow down our search. So we're going to use the roots just like we did yesterday, because now that we have roots, we can use synthetic division. So we're going to choose one of the roots to use. It doesn't matter which one. I'm going to use -2. Okay? So I'm going to pick -2 to use for my root and use synthetic division. So I got to make my box. What goes in here? Well, that's going to be the -2, because I would put my root in my box. I don't need to switch the sign when I have the root. And then I'm going to write out my label. So I have to go back to this polynomial here and pick out the highest degree, which is x to the 4. So x to the 4, x to the 3rd, x squared, x, and the constant. Then write out my coefficients, which is 1, -1, -5, -1, and -6. And so I bring down the 1 first, and then I multiply the 1 with this -2. Multiply this 1 with this -2, which gives me -2. And then you always want to add your numbers vertically. So -1 plus -2 gives you -3. -3 times -2 gives you +6. That would give you 1. 1 times 2 gives you -2, which is -3. -3 times -2 gives you a +6, which is 0. Okay, so looking at this here, that means that our factors, our remainder is 0, so that means that this is a root. Confirms it. Let's figure out what we got when we divided. So it looks like we have x cubed minus 3 plus x minus 3. And from here, we would factor on more. So because we have something to the cube, right, that means that we can try to use perhaps, sorry, I think I messed up on my sign when I'm looking at this. I dropped my x squared. I knew there was something wrong when I looked at this. So I have x squared plus x minus 3. And so looking at this, we would need to use grouping to factor this a little more. So I would use grouping. So I can take out x squared, which leaves behind x and minus 3. For this one here, there's nothing in common with this term and this term, so I'm going to just leave it the way it is. Like, I can't take anything out from this x because this doesn't have an x, and I can't take numbers out because 1 and -3 don't have anything in common. So I'm just going to write this as plus x minus 3. And remember, there's always like a 1 in front of this parentheses here. So these two factors are the same, so I can pull out x minus 3. But I left behind x squared and 1. So looking at this here, I would set these factors equal to 0, right? So here's the thing. X minus 3 equals 0 is just, let's see if I can kind of move this over here. There we go. So when I look at this here, this one, if I set equal to 0 and add 3 to both sides, x is equal to positive 3. Well, I already have that here, right? So in that case, since I already have x equals positive 3, let's move on to the next one here. So if I set this one equal to 0, I would subtract -1 to both sides. X is equal to -1. Take the square root of both sides to get rid of the square. Anytime you take a square root, the 2 and the square root cancel, and you have to have a plus or minus in front of your square root. Because there's a negative in our square root, we have to have an I. Square root of 1. Square root of 1 is just 1, so we have 1i. And that is one of our root, which is our imaginary root. The other two roots that we found was the one from the graph, right? And so these are our other two roots. So it looks like our roots, our four roots are -2 and 3, and plus or minus I. So if you want to write this all in like one nice answer, because that's bothering you, that's in different boxes. So x is equal to -2, 3, and plus or minus 1i. And that is your final answer.